For our last problem, we were asked a container in the shape of a right cylinder with no top, which means there is no top up here, has a surface area 3 pi feet squared. What height h and base radius r will maximize the volume of the cylinder? There's a radius and there's our height. So we know our surface area without a top is just pi r squared plus 2 pi r h. And we know our volume is pi r squared h. Now first we want to find an equation for either h or r. We decided to go with h, and we plugged 3 pi equal to pi r squared h plus 2 pi r h. Solve for h, and we got h equals, 3 minus r squared over 2r.
So now that we know h in terms of r, what we can do is substitute that h into the volume equation and then solve for r. So volume is pi r squared h, or in this case, it's going to be volume is pi r squared times 3 minus r squared over 2r. We can distribute the pi r squared and get 3 pi r squared minus pi r to the fourth over 2r. We can factor out an r from the top equation and from the bottom equation and cancel these r's out. So we can get, now that we know the volume formula right here, we can take the derivative of that, and we get the derivative to be 3 pi over 2 minus 3 pi r squared over 2. We can set the derivative of this equal to 0, and then solve for r. And when we do that, we get that r is going to be the square root of 1, or just 1. Since we know that r equals 1, we can plug that back into the h equation, 3 minus r squared over 2r. And when we do that, we get that h also equals 1. So if you notice that h and r both equal the same thing, what we find is that is the principle of cylinders. When the height is the same as its radius, that's when the volume of them is really maximized.